All right, so this is section 3.5, and we are going to be looking at dividing polynomials. So in this section, we will see two different methods. The first one we will look at is called long division, and the second one is called synthetic division. Now, before we start doing long division with polynomials, let's just do a quick review of what division with long division looked like back in elementary school. If you had 62 divided by 4, this was called the dividend. This was called the divisor. What we ended up with was our quotient. If we had anything left over, that was called our remainder. So the question we'd kind of ask ourselves back in elementary school was 4 goes into 6 how many times? And we would say 1 time. 1 times 4 gave us 4, and then we subtracted. So 6 minus 4 gave us 2, and then we brought this 2 down and repeated the process. So then 2 goes into 22 how many times? Or I'm sorry, 4 goes into 22 how many times? We would say 5. 5 times 4 is 20. We're subtracting, and I'm left with 2, and 4 no longer goes into 2. There's nothing left to bring down. So that is called my remainder. And my answer would be 15 and 2 over 4, or 15 and 1/2 as my answer. So we're going to do something really similar with dividing polynomials. And in these examples here, we're going to set it up the same way. So what we are dividing goes inside the little division bar. So I have x squared plus 10x plus 21. And then what I'm dividing by comes out front. So x plus 3 is out front. And the way we're going to ask the question is going to be slightly differently than with just whole numbers here. We're going to be asking ourselves x times what gives me x squared. And we want both of these things to be in descending order. So largest exponent, next largest exponent, all the way down to the constant. And then the same thing out front. We want it in descending order. So if I am setting this up here like this, again, I want to ask the question, x times what gives me x squared, and that would be x. So x times x gives me x squared, and then x times 3 gives me 3x. But remember, just like we did with the numbers here, we are subtracting. So that whatever signs were there initially will switch. And now those cancel out. I have 10x minus 3x gives me 7x. I bring down my 21, and then I repeat the process just like I did with regular long division. So I'm asking myself, x times what gives me 7x? That would be 7. 7 times x is 7x. 7 times 3 is 21. But again, we are subtracting, so those cancel out, and it happens to be that these also cancel out, and I don't have a remainder. So remember, when you were doing division with just numbers like we did before, if you got a remainder of 0, that means that the number divided in evenly. It meant it was a factor of that number. Well, it means the same thing with polynomials. X plus 3 then is a factor of x squared plus 10x plus 21, and so is x plus 7. So my answer here would be x plus 7. Let's do another example. And here we can see that this is not in descending order. So the first thing I need to do is get this into descending order. 6x cubed minus x squared minus 5x plus 4. And we're dividing by 3x minus 2. So I'm going to go through this process again. I'm asking myself, x squared or 3x times what gives me 6x cubed. And before I continue on, let me go back actually to the previous example here and point out something that I did that I should have talked about a little bit more. Notice that my x squareds are lined up vertically throughout the problem. This whole column here is just x terms. Here is just constants. It's really important with long division to keep your work organized. So I didn't put the x, my first one, I didn't put that over the x squared. I put that over the x term so that throughout my entire problem, these are all x's. These are all constants, and so on. So I'm going to do the same thing in this next example. So again, 3x times what would give me 6x cubed? That would be 2x squared. 2x squared times 3x gives me 6x cubed. 2x squared times negative 2 is negative 4x squared. But remember, we are subtracting, so those signs switch and those first terms cancel out. And every time we should see those terms cancel out. So now I'm left with 3x squared, and I can bring everything else down, and then I'm repeating the process again. So now I'm asking myself, 3x times what gives me 3x squared? Well, that would be x. X times 3x is 3x squared. X times negative 2 is negative 2x. But remember, we are subtracting, so those signs switch. And now I'm left with negative 3x and bringing down that plus 4. Going through the process again, 3x times what gives me negative 3x? That would be negative 1. Negative 1 times 3x is negative 3x. Negative 1 times negative 2 is positive 2. But remember, we are subtracting, so those signs switch. And I'm left with a 2 as my remainder. So the way I would write my answer now is 2x squared plus x minus 1 plus my remainder over what I divided by, just like we did with numbers. And that is my answer. Let's do one more. In this next one, it is in descending order, but I noticed something unique about this one. I have x to the fourth power, x to the third, and then I don't have an x squared term. And if you have a missing term like that, you're going to need to use a placeholder. Another thing I noticed that's different about this one is that I have an x squared minus 2x. So we have 2x to the fourth plus 3x cubed plus 0x squared minus 7x minus 10. And then I have x squared minus 2x. If this had said x squared minus 2 instead of 2x, I would need to use a placeholder for the x term on this side as well. And long division is the only type of division we have where we can divide by something that's not linear. So the previous examples, these were all linear factors. My x was just to the first power. There was no x squared over here. Synthetic division, which we will see in a few minutes, is much shorter than long division. But long division is the only thing we can use if we're dividing by a quadratic or higher factor. Synthetic division can only be used when we're dividing by a linear factor. All right, let's continue. So here we have x squared minus 2x going into 2x to the fourth plus 3x cubed plus 0x squared minus 7x minus 7. I want to ask myself, x squared times what gives me 2x to the fourth, and that would be 2x squared. And again, notice I'm keeping things organized. I put that above the x squared term. So 2x squared times x squared gives me 2x to the fourth. 2x squared times negative 2x is negative 4x cubed. But we are subtracting, so those signs switch, and this term cancels. And we have now 3x cubed plus 4x cubed is 7x cubed, and everything else is coming down. And so we're asking ourselves, x squared times 7x cubed gives me 7x, or I'm sorry, let me rephrase that. X squared times what gives me 7x cubed? And that would be 7x. 7x times 7x or times x squared is 7x cubed. 7x times negative 2x is negative 14x squared, but we are subtracting, so those signs switch and those cancel. And now we have 14x squared minus 7x minus 10. And we go through this process one last time. X squared times what gives me 14x squared, and that would be 14. 14 times x squared is 14x squared. 14 times negative 2 is negative 28x. And then we are subtracting, so signs switch and those cancel. And I'm left with 21x minus 10, and that is my remainder. Your remainder can have two terms. So my final answer then is 2x squared plus 7x plus 14 plus 21x minus 10 over x squared minus 2x. Okay. So that's long division. We are now going to look at synthetic division. And synthetic division, when you first see it, feels kind of random. Like, why are we doing the things we're doing? How does this work? But it's a lot less writing, a lot less work, less organization. So it's easier, but it looks different and is a little bit hard to get used to at first. So sometimes students will ask me once I show them synthetic division, why would I ever use long division? And again, back to this example here, if we have something that we're dividing by that has an x squared or x cubed or anything bigger than just an x, bigger than a linear factor, then long division is our only option. I cannot use synthetic division for things like that. So synthetic division here. And this little division algorithm thing I'll come back to in actually the next section. But we have here that 5x cubed plus 6x plus 8 divided by x plus 2. In synthetic division, we will still have a little box, just a little bit different, and then a line down here. And this is still kind of going in that little box off to the front. And the way we figure out what's going in that box is we're setting that equal to 0 and solving. So x plus 2 set equal to 0, then x equals negative 2. And then notice here that I have a missing term. I go from x cubed just to x. There's no x squared term. So just like with long division, I will need a placeholder. And these numbers are going to go right here, but we're just using their coefficients. I'm not actually going to have any x's in this. So I will have 5, 0 for my placeholder, 6, and then 8. So you have the perk of this being a video, and you can pause and rewatch as many times as you want. So my suggestion would be don't try to write right now. Just pause the video after we're done and copy it down afterwards. But you don't want to miss the process here. So the very first thing we're going to do here is bring our 5 down. So the 5 comes down. And diagonally, we will be multiplying, vertically adding. So negative 2 times 5 is negative 10. And then I'm adding here 0 plus negative 10 is negative 10. And then I continue to repeat that process. Negative 2 times negative 10 is 20. And then 6 plus 20 is 26. And then negative 2 times 26 is negative 52. And then 8 plus negative 52 is negative 44. And that last number is our remainder. So if that last number is 0, then that means it divided evenly, just like we saw with long division. But if our remainder is a number, that means we still have something left over. It did not divide evenly. And then how we translate this back into a polynomial is this is our remainder, this is our constant, our x squared. And if I had more terms going this way, that would be x cubed and so on. So my answer is 5x squared minus 10x plus 26 plus negative 44 over x plus 2. Okay. So that is synthetic division. We're going to do one more example. And in this next example, you'll see it's not just x plus 2, but there's a coefficient on the x. And so make sure to notice here that when I set that equal to 0, I add the 1 over and divide by 2, and x is equal to 1/2. So now what I'm dividing by is a fraction. So setting that up in my little synthetic division fraction bar thing here. I have no missing terms. It's already in descending order, so I can just write those down to negative 11 and 5. And the first thing I'm going to do is bring down the 2. And then I have 1/2 times 2 is 1. Negative 11 plus 1 is negative 10. 1/2 times 10, or negative 10 is negative 5. 5 plus negative 5 is 0. So I have a remainder of 0 here. That means it divides evenly. So if I have 2x squared minus 11x plus 5 divided by 2x minus 1, my answer is 2x minus 10. Now, what we've actually divided by here is not 2x minus 1. What we've actually divided by is x minus 1/2. And this is what you'd have to multiply this by in order to get back to the original. Okay, what we've essentially done is divided this factor by 2. So I'm going to come back to what was at the very top of the page here real quick. Basically, this is what we're using for doing synthetic and long division. If I have some polynomial f of x, if I multiply the divisor by the quotient and add the remainder, I get back to what I started with here. Okay, so that's just kind of like, if it's easier to think back with numbers. If I were dividing 20 by 4 and I got 5, or let's actually use something that doesn't divide evenly. Let's use 21. So that would be 20 and then with the remainder of 1, and my answer would be 5 and 1/4. So what we're saying here is 4 times 5, my divisor times my quotient, is 20, and then plus 1, my remainder, and that gives me back to 21. And that's what we're using here. That's the division algorithm. Down here, we have what's called the factor theorem. And if a factor is, if it divides evenly, then when we plug in that factor, we should get 0. We will use this a lot in the next section, and it will be a really helpful tool for us, but for testing possible factors. If I have some factor, so x minus c, if that's a factor of my polynomial, then when I plug in c, I should get 0. Vice versa, if I plug in some value c and I get 0, then that means this is a factor of f of x. And like I said, we will use that in the next section a lot more. This last example here, it says the volume of a rectangular solid is given by this polynomial here. So this is telling us the volume. The length of the solid is 3x, and the width is x minus 2. We want to find the height of the solid. So we have some rectangular solid, basically an irregular cube here. Okay. And we're told that the volume is equal to 3x to the 4th minus 3x cubed minus 33x squared plus 54x. And then we're told that the length is equal to 3x and the width is equal to x minus 2. Now, if these were just numbers, if I said the volume, let me do this in pencil so I can erase it. The volume is 100. And then I told you that the length was 2 and the width was 10. And I said, find the height. So we want the height of this solid. Well, we'd take 100 and we would divide it by 2 and then divide it by 10, and that would give us our height. But we don't have numbers, we have polynomials. So we're going to do the same thing with polynomials that we would do with numbers. It will just be a little bit more work, but actually not that bad. Now, it tells me my length is 3x. I notice that all 4 of these terms are divisible by 3, and they all have an x on them. So the very first bit of division I'm going to do here is with the length. I'm going to divide this whole thing by 3x. So if I factor out a 3x here, I'm left with x cubed minus x squared minus 11x plus, and then 54 divided by 3 should be 14. Check that. Oh, 18. That's right. So, and then we have 3x. And now that that 3x has been factored out of everything, these two can be canceled out. And then I'm left with x cubed minus x squared minus 11x plus 18. And now I'm going to want to divide by my width. So I can either use synthetic division or long division to divide here. I'm going to go ahead and use synthetic division. In my box, x minus 2 set equal to 0 would give me 2. And then I have 1, -1, -11, and 18. And I don't need any placeholders because there's no missing terms. Bringing my 1 down, 2 times 1 is 2. -1 plus 2 is 1. 2 times 1 is 2. -11 plus 2 is -9. 2 times -9 is -18, and that gives me a remainder of 0. So that means that this polynomial here, x squared plus x minus 9, is my height. So the height for this rectangular solid is x squared plus x minus 9. And we've answered the question. And that brings us to the end of section 5.